great. So I hope you can all hear me here. Thanks to Andrea and Eric and Andy for organizing this symposium. I think it's fantastic. Our lab, we've been here at Columbia for 15 years in Columbia Engineering, and we've always been working on point of care diagnostics. It's been probably the main focus in our lab. So we've been trying to work on this COVID problem for the last few months. And just due to time and also, that this is a work in progress, and to just have an open dialogue, I'm going to keep things pretty high level and really talking about three of the things that have been in the news and that our lab has been working on with a variety of partners. Start off with the RT-PCR test, which is the sort of the original test that everybody has been talking about. This is the swab test to see whether or not someone has a viral load. I'll move on to talk about the serology tests, which are primarily antibody tests. There are some efforts to look at antigen testing, but I think really the main focus is on antibody testing, both for surveillance and also for getting people back to work. And then talk about some efforts that we have been working on, also with Shifu Chang in the engineering school on mobile tracking, which is a problem that we have been working on for a while, but we think what's going on right now is really illustrating some of the basic tensions, if you will, in point of care diagnostics, and perhaps using mobile devices can be a way to overcome this. And just again, at a very high level, we wrote this review a few years ago for anyone interested in looking at this. We're very open to collaborations, and we're working away right now in our lab. So anybody who wants to contact me, please do so. But we were talking about both sort of just reviewing the state of the art in point of care from both a technological and non-technological point of view. And I think, just a couple of quick points here. What we're seeing in the COVID challenges right now in the diagnostic space, I think is really laying out to bear what the issues are in general in the point of care diagnostics space. Both of these tests, RT-PCR and the serology tests, are very simple tests from a technical point of view. So we're not looking at redeveloping some new science out here. But despite their simplicity, we've run into a myriad number of challenges, which I just, we don't really have time to get into all of that. I think you've heard about some of that in the news. But really, I think the issue is how to offer these, even though they're technically simple tests, how to offer them at a high degree of quality assurance and at scale, going from 0 to 60. That's still very difficult. And all the challenges in the diagnostic space when it comes to the supply chain, quality assurance, and really just ensuring that companies have a proper incentive to develop these tests. All of these issues are still existing. And I think it's, in a nutshell, it's leading to some of the challenges we're facing right now, not because these tests are hard to do, but just because how can we scale them up properly? The other part of this is we made this point about different point of care devices, point of care diagnostics that are out there. Point of care actually covers a whole wide range of use cases, at least 4 that we try to identify here, that are linked to the way the devices are actually designed. So it's not just that point of care is a point of care test. It really depends on whether or not you're talking about doing this in a clinic versus out in a remote area, and the budget that's available, the training of the people that are available. So again, I'm keeping this a little bit high level, but just going through what the issues are here and then what the opportunity is for us to contribute. This was taken from a recent consulting company, just a pretty random one, but they've also sketched it out in their own sort of axis here in terms of trying to design devices for different settings. We're talking about the molecular test here, and there's a bit of a trade-off between the throughput and the turnaround time. That's one way you can plot this. And I'll actually show you a high throughput test, which is appropriate for use in a lab, and then a more point of care tests that could be used in a lot of places, but that are lower throughput. So you see this, for example, Roche Thermo Fisher also has a high throughput test for COVID now, but these are really meant to be used in a big lab setting, and it's very hard to just sort of have different labs buy these very expensive machines and to really stand up that kind of testing for a whole variety of reasons. And so really, that is a model, is to feed everything through centralized labs, but we are seeing the limitations of that. There is also now, on the other end of the spectrum, news about this Abbott device, and this was actually a device from Alere before. That was the Alere eye test. Abbott bought Alere a couple of years ago. This is a test that could be done one sample at a time in about 5 to 13 minutes. And it's, it's been in the news, the White House has been talking about it, but it's still expensive. And again, not to get into sort of the diagnostics industry details here, but I think these are going for $10,000 each. And so there's an installed use base of maybe, I think 18,000 if I get it correctly. So really, I think that is the kind of solution that we're interested in, because you're hearing about parking lots, you're hearing about drive-through clinics, you're hearing about deploying these diagnostics in a lot of different places. And I think that is going to have to be the way to go if we're going to be testing 100 million Americans. It's simply impractical to be funneling everything through a small number of centralized labs. There are only maybe 2,000 or 3,000 of these in the country, but making these tests decentralized would be wonderful. So our lab works on microfluidics, and really, I think, again, the challenge is how do you offer these tests actually with reagents that are not controlled from an intellectual property point of view. At the beginning of this, there was a shortage of QIAGEN RNA extraction kits, and there's really actually nothing that special about these proprietary reagents. A lot of times they're proprietary because they don't want to let you know how simple they are. There's about 10 different ways of extracting RNA. And so I think this is making, I think it should make us all rethink how this kind of diagnostics should be done, working with just well-established reagents to do the extraction, and then using an automated method that is controlled, and that is lower cost than $10,000 per instrument, so that this could be done by anyone, a swab test, and that could be really being distributed to all sorts of places. So our vision is not too far from this Alere point of care test, but we don't think it needs to be $10,000 a pop. And we're also trying to do this with RT-PCR. Their test is an isothermal test. If it runs well, it's fine. They're using a nicking enzyme test. We're going back to the gold standard of doing sort of what all the CDC and all these other tests are, looking at a few gene markers using thermal cycling. We think we can do it really fast now. And in fact, we're working with a startup that I started. We were looking at flu testing and so forth before, and now we're repositioning for COVID. But we can do this thermal cycling either with a battery, or we have this photothermal setup where we can also do the entire 30 cycles in about 5 minutes. And then we also have to do the RNA extraction on top of it. So the whole test could be run less than 10 minutes, perhaps in a microfluidic cartridge, so it's well controlled. This is actually not in microfluidics, but is something that in this setup could still be well controlled. And really, that's the point, is maintaining that quality.
Your 9-minute mark.
Okay, great. I'm just going to have to move on pretty fast then. So let's get to the serology test here. The antibody test is something that has been in the news. And I'm not going to talk about the antigen test because that there's not a lot of evidence that I've seen that you can look at antigens early on. The antibodies, I think, come usually about 10 minutes after, 10 days after the onset of symptoms. So it's sort of later stage infection. Also tells people whether or not you have been infected, which is a big issue now about getting people back to work. And I'm pointing out one of these tests that has been, BD has agreed to distribute. David Ho's lab, we're working with him. We have actually been looking at this test for about the past month and really looking at how well they work. And long story short, you're seeing in the news a lot of people claiming these rapid tests are approved by the FDA. It's not true. Actually, the FDA has not approved a single point of care serology test. They issued a guidance document saying that these tests can be distributed. They don't object to it, but really people should be pointing out that they're not FDA approved. They're only allowing them to be distributed because they're sort of low complexity tests. Anyway, we have been also working on this, and courtesy of our dean's office, we recently did get a hold of this, purchase this equipment. It's in the Lasker building, which is where my lab is, and there's been actually a back order in this spotting equipment, because this is the equipment that's behind a lot of these lateral flow testing. So we're open to working with people across the campus on making recombinant antigens. There's been issues, I would say, in getting access to specimens. I've been very interested in working with Eldad and pathology and maybe Wendy Chung's group. But even for us, where we do this for a living, it's been exceedingly difficult to get a hold of the specimens. And I think it's actually limiting not just our work, but a question is, why aren't there more tests out in the country? And I believe getting access to the specimens are the lifeblood of developing diagnostic tests. And it's been very difficult so far, not because of anyone's, because everyone's just been working on fumes. There's a test that I had co-founded, and it's being run by OPCO on a serology test, and maybe there's a ways to get that up and running for serology as well. Last thing I'll talk about, I'm running out of time, is on mobile tracking. And this is an issue where as these tests are getting out there into the market, even but for consumer testing, which is not happening right now anywhere in the world yet, but there's an issue of how to inform the consumers of the right steps to take, as well as linking them to care. And so we have been working on this, for example, in Africa. We have a version of this with Ivan Balan, looking at HIV STI testing and having home users take pictures of the tests, and we would automatically use machine learning algorithms to interpret the tests. And we have a collaboration right now, which I'm not going to get into, on maybe scaling this up nationally into a pandemic.
I'm running way over time, so.
Okay, well, I'll just end here. Working on machine learning efforts, and we'll take questions if there's time. Thanks.
Okay. Any question for Sam? We have a question from Aaron.
Yeah, just you know, it's been more of a pop question that has come up, is this idea of administering a test at home if you're feeling, you know, not like you want to go wait in line, as an example. So I want to just get some of your comments about that, Sam.
Yeah, I think it's going to happen, but one thing that is, for example, the UK ordered 17 million of these tests, and Oxford is testing them and showing that they're not working. It's really the Wild West. The FDA has been under pressure to let these tests be used, but the issue is, I think a lot of companies have been taking advantage of this loophole, and they've been claiming things that have just simply not been true, which I won't get into. And so the FDA so far is allowing actually providers to be purchasing these tests. And again, there's reimbursement issues. And so a lot of those issues are being laid bare in terms of the limitations. But the FDA is not allowing these tests, which I think is a good move right now, not to be allowing them for home use, again, because it's going to be the Wild West. And I think pairing it up with a mobile app is one thing that we're trying to work on, so that the consumers get the proper interpretation and they get the proper information. Otherwise, people will just not know what to do with the information. They're not getting an acute result here. And so I think it will happen, but the manufacturers, I think right now, are taking some shortcuts. A lot of them are actually outside the US. They're offering these low complexity tests. They don't work very well. There's still improvements that have to be made, and we've seen this before with HIV rapid tests, et cetera. And so we're working again with David Ho's lab, where we're open to working with other groups at Columbia to maybe slow things down a little bit. It's an urgent situation, but we can't just be releasing tests out there that don't work. And then again, pairing this with a mobile app that will help the consumers interpret the information. I think that's going to be the way to go.
Brant, I promoted you to panelist. Do you have a question?
Yes, Sam, can you hear me okay?
Yes, hi,
all right, great. Yeah, great talk. I had a question about the serological test. So is the false positive in that test biological or technological? Meaning, if you repeat the false positive, if you repeat the test on the same person and it's a false positive, would it come back false positive again because of some biological reason? Or if you just repeat it, then you would overcome that. And then, do you know there's data to show those people would not be reinfected?
So on the first one, I believe that you would get an antibody result, and it's a matter of how long it takes. Some companies have gone on to saying, I've seen people say that you would get this one day after symptoms, which I just don't think is true, even though I've seen some of those results. So I think it's a matter of just, are we talking about 7 days after symptoms? Are we talking about 10 days? Are we talking about 15 days? And if you do a retesting, I believe you will get a positive antibody response at some point. It's a matter of exactly how many days. I would say that after 2 weeks, most of the results so far would show that you have a proper.
Sam, I think Brent's question was about the reproducibility of the false negatives. So if you get a false or the false positive, so if you get a false negative or false positive and you repeat the test right away, would this still be a false negative or false positive?
Right. So I think I was trying to answer the false negative for the serology. If we're talking about the RT-PCR test, that's tough because we don't always get viral shedding at various stages of the infection. So that one, I think you're just always going to have some degree of false negative with the molecular test. The antibody test, I think you will get that antibody for sure at some point. The reinfection is a complicated question right now. I think what we're seeing in the most cases, as far as I can tell, is people who have just been testing false negatives and they're not getting reinfected. It's just that there's a reservoir there. That's as far as I can tell is what's going on.